Greetings, this is Edodo Jumbo. In this tutorial, I'm going to show you how you can train your own generative AI using the TinyGPT 124M model. Also, if you join me in the live stream, you're free to ask any questions about programming and lifestyle topics. And as you can see here, you simply just go to the live stream, click here, and then you can watch, or you can watch it below. So in the live stream, obviously that's where you can post your requests. Also be sure to subscribe, like, follow, and leave comments for more frequent content. With that said, let's continue the tutorial. Okay, so the TinyGPT is an open source model. It's a lightweight version of the GPT-2 and can be trained for a variety of tasks. So what I will do is I'll walk you through how to install it. It's the 124M, so it's a very small one. It's actually called tiny. So the M stands for parameters. For example, usually we've been working with B, that's obviously billion. M is also million. Hope that's simple enough. And we're going to do it in a Podman Compose container. Why use a container? So a container, this way you don't, one of the things I dislike about Python is that it's very easy to install things, especially with Py, but then when we install other dependencies, it's very difficult to remove them. But if you put everything inside a container, it makes it more reproducible, meaning that I can show you my YAML file, for example, for Podman Compose, and you will do the exact same thing, whether you're running something like, say, a Raspberry Pi, whether you're on Linux like I am, and Fedora Linux, or you're on, say, Mac OS or Windows, you'll be able to replicate exactly what I'm doing, right down to the version number. So that's what makes it a pretty useful tool. So we're also going to train the model on a custom data set. We're going to create our own data set to make it even more, I guess, free and open source. And obviously we're going to use Podman Compose to containerize the environment for the training. And then finally we're going to train our model. So we're going to create all the necessary files. We're going to create a file which actually creates our data set. We're going to create the train for training and then to test it as well. And obviously we're going to create a Docker file. So you can follow, if you don't have Podman installed, you can, if you have Docker, you can, it's a drop-in replacement. So you can basically take all my commands, just replace Podman with Docker. The reason I like to use Podman is because Podman is rootless, meaning that you can run it as a regular user. The problem with Docker is sometimes it does need you to run things as a root user. But with Podman, you don't need to do that. That's why I prefer using Podman. And also its license is, it's not ambiguous. Okay, now with that said, you're going to need Podman, of course, Podman Compose. So Podman is a container management tool. As I said, it's an alternative to Docker. Podman Compose, that's one that manages multi-container applications. For example, what I mean by that is one container can have Python. The other container will have the large language model, and so forth and so forth. So that's why I prefer using Podman Compose. Now you can run everything with Podman, but keeping them in separate containers is actually a good idea. For example, you're also going to need to have Python 3.6 running for training and testing scripts. That's Python 3.6 or above, at least at the time of this recording. And then we're going to get the GPT-2 from Hugging Face. So you have to remember with Hugging Face, the truly free open source models, those one you can still download for free, but the other ones which kind of ambiguous are not quite free. Basically, how do you know if something's open source or not? If it puts restrictions on its use case and whatever, that's not open source. So that's why you do need to sign in to agree before you can download those. And of course, we're going to use our own custom data set. It's just JSON is just a text file. Okay, with that said, let's get started here. So I in order not to waste too much time, I've already created this file. So I'm going to open up all these files and I'll show them to you. So we don't actually need this file, the custom data, because that's going to be created for us. So I'm going to open up all these files and I'll show you what they actually look like. I'll use the Oops. Let's close them up here. Is there open with? Yeah, we go open with. I want to open up with the text editor. There we go. It opened up in the wrong. It opened up in Guinea. Okay, there we go. So let's check them out here. Okay, so let's look at the Docker file first. Okay, so here's the Docker file. As you can see, it's going to grab PyTouch, the latest version. So that's going to be a container. And then it's going to create a folder called /mount scripts. And then inside the container, of course. And then it's going to install, you see pipe, it's going to install the transformers, the torch version, accelerate, and datasets. These are all libraries or necessary dependencies. So as I said, if you try to install this, you have to use the pipe command. If you install this on your system, it's going to leave a lot of crap. There's no way to simply just remove them. Like there's no like uninstall and uninstalls the stuff you did. So that's why putting in a container is much easier. And I said you can easily replicate this. So of course, then what we'll do is I'm going to have my train Python file. It's going to put it into /mount scripts /train inside the container. Then it's going to take my test.py file and put it into the same /mount /scripts folder inside the container. Then I create another environment called hf_home, that's all caps, and that will be in /mount cache Hugging Face. The reason we do this is because when we download a model, every single time we run this container or the Podman Compose, it's going to try to download the model over and over again. Now it's only 124M, so I don't know how big that is. I think it's probably 500 megabytes or maybe smaller than that. That's not the point. The point is that imagine if it was a very large model. You know, you don't want to be downloading it over and over and over again. So that's why we created this cache. So it's optional, but it's better to cache it, that way it doesn't download over and over again. And then finally, this command, Python 3, comma, then /mount scripts train.py. So train.py will train it. Okay, so then after that we have this, let's go to the Podman YAML file. And as you can see, I'm using version 3, but you can use version 3 or version 3.7 or 3.8. So you can see the services is TinyGPT -train and the build. So when you put the build, I just put a dot or period. What that will do is it will automatically grab the Docker file and other files relative to its path. Now, if you're somewhere else, you'd have to put the actual path, but I prefer this way because I always I like to keep things separated. So everything here is only for this particular build. And then the container name is TinyGPT _train_container, simple enough. The ports I use 8080 and map it to 8080 inside the container. That is because I rarely use port 8080. It's unless I'm running something like Composer or PHP. The only other time I use those ports is when I'm running PHP's or Python's built-in server, but that's rare. Usually when I'm done, I'll then have, for example, I'll use Nginx or Apache. And here are the volumes. You see the custom data. The custom data will be obviously mounted in the /mount /data custom data text, and then the train py, same thing in the same /mount /scripts, and the which one is this one? This is the testing script will be mounted in /mount /scripts /test.py, and the cache, the .cache, will be /Hugging Face will be mounted in /mount /cache /Hugging Face. So what does this mean? This means that when I download, if I download the model manually and I put it in the .cache Hugging Face folder, it's a hidden one. That's why you see the dot there. It will automatically be mounted into the container. So this way, it gives you an option where you can mount the LLM yourself. For example, if I download it previously, I can just put it there. So this way it will be a little bit faster as well. And of course the environment, the model underscore name, all caps, equals GPT-2. So as you can see, it's that's the actual name. Even though it's called TinyGPT, it's actually GP2-2, and that's the one that's 124M. And then the command for this is Python 3 space /mount/scripts/train.py. Of course, this overrides the one in the Docker file. The reason for that is because I don't always need it to be running, and that's because I just need to be trained once, and then after that I can run my own tests. Or if I have different tests, I know it will be easy to explain much when we run this. So then I have this one, they create custom data sets. Let me zoom in here a little bit. So I just some randoms. Basically, I have some sample sentences, and then as you can see here, this is the method, create a data set. The file name will be custom underscore data.text, and you see the number of samples will be 100, and then we just use a with loop, open file name right as f, and then for in range number of samples. Remember it was 100. The sentence is just random choice, so pick on this random choice sentence, and then it will basically just add it there, and it create, that's basically it. So it will create 100 of them, and then it will create the custom underscore data.text file. That's literally it. Okay, so let's go to our test.py. So it uses transformers, imports it from GPT-2 LM head model, and also the GPT-2 tokenizer. And as you can see, it uses our cache folder. So this, I'll explain this in a second. So when it downloads the model, if the model already exists, it won't download it again. That's what this does. See the tokenizer from pre-trained cache, the cache underscore dir, that's the folder, and the model is the GP2 LM head model from pre-trained, the cache and underscore there as well. The model dot eval, then the input text, the weather is great today. Then the inputs, it will say input, you get the input text, and this the return underscore centers the point. The outputs will generate input IDs. The max length will be 50, and they return the sequences. Then the generate text to decode the output, and using special tokens, I set it to true. Skip special tokens, I set that to true. So just print the input, and it will generate the text out there. So that's our test. And then for the training, as you can see, it's very similar to our test. Again, from transformers, we get the head, tokenizer, and the trainer, and the training arguments. And then, of course, we need to load the data set. So the cache folder, our directory, you can see /mount/cache Hugging Face, and then tokenizer, again, same thing with the model. And here the tokenizer .pad underscore token, we use the tokenizer.eos underscore token. And then after that, we also want to create a log folder. This is very, very important. In case anything goes wrong, it's a good idea to see what happened in the logs. So you see, you can log into the logs folder in the container and find out what went wrong. And then after that, we have trained the data set. Remember, we're going to use our custom data set, and we split the train just in case it's too much. In our case, it shouldn't be a problem. And here we have our method to train the So basically, we take the examples, tokenize them, padding true, tokenization true, input IDs, encoding. This is very similar to the test. Then we clone it, and then we do the pad token ID minus 100. Just ignore the padding tokens and loss calculation, and encoding labels, and then we return the encoding. Then after that, the tokenized data sets with dataset map, and tokenize the function in a batch. So in our case, when you have basically one file, so this is a little I don't want to call it overkill. Obviously, this is just a beginner. You can obviously do as much as you want. So here's the training arguments. As you can see, I the cache there. That's the folder where our model is going to be. Remember, basic. So I hope I'm not confusing people. Basically, we have two models. We're going to have the base model, and then we're going to have the trained model. So once we download the model, that model is going to be cached. And then we want to, going forward, to use our trained models. Every time we can train it all the time. So hopefully that makes sense. So that's why if you see your file size or the amount of space being used is saying, hey, why is this increasing? That's why, because we're going to train our so we're going to have two models, the base model, and then we're going to have our trained model. Hope that makes sense. So that's why be careful if you're getting a very large model, because it's going to be more than double the size, because as soon as you train it, it's going to get a little bit bigger. Okay, so the number of training epochs is set to 1, the per device trained batch size set to 8, the save steps is 10,000 or 10_00, logging directory, remember we created a logging directory before, and logging steps I set that to 500, and save total limit I set it to 1. And you see the trainer, the model, obviously the arguments are training arguments, and the trained data set, the one, the tokenized data sets. And after that, it's usually just to train, and this should be very quickly. So we save the pre-trained into the cache folder, and tokenize also save it into the cache folder. All right, and then after that, I believe that's all the files here. So I'm going to minimize this, and what I want to do is, the first thing I'm going to do when I run this is I'm going to run our okay, so let's open up the console here. I'm going to run the dataset first to create the dataset, just so that I do not forget anything. This should be pretty quick, thankfully. Okay, so the first thing you do is simply just type Python and then create dataset. So let me show you what that would do here. Let me actually put it, where is the, always on top, there we go. So you can see here, so when I run this, you see it has created the data set. Now I'm going to open this up just to show you what it looks like. So it created 100 samples. You see, this is the 100 samples it did. You see, for example, the village was known for its peaceful atmosphere and beautiful flowers. At the edge of the village, a mysterious forest grew, etc., etc. See, it created all this. You can see there, just that's how they all are. As you can see, basically, there's no, this one is repeating, but you can see it does things a little bit differently. Okay, so let's minimize that. Now, with that said, so I've shown you. So what I'm going to do now is pretty simple. Is I'm going to what we're going to do now is I'm going to you see when I type Python here, some of you you should not have this, but if you have Python 2 or Python 3, you need Python 3 for this. Sometimes you might have typed Python 3 space create_dataset.py, but I only have Python 3. Okay, next thing is we're going to use Podman Compose. So Podman_compose up, then space 2 hyphens, and then build lowercase. So when we do that, as you can see, it's pulling the PyTorch from docker.io. and it should in the cache, which I didn't show you, it should have already gotten the model. I'm actually going to check it out just while this is running. Let me check to make sure that it does have the cache. Let me see, it should be .cache. .cache. So I'll show you my cache folder. And what was it? Hugging Face. HHH. Yeah, Hugging Face. You see Hugging Face? See, it already has some of this. You see, it has some data sets from previously. So, and you see the models are here. Models --GPT2. So if we go in here, you can see these are the blobs. So I already downloaded the model before, so because it's in cache here, so it should be a little bit faster. Now, you see here it's .cache, it's in my home folder. Now you might be asking, why did I put it in the home folder? Why didn't I put it in the same relative to where the training is? The reason for that is because today in this tutorial I am training GPT-2, the TinyGPT. But in the future I might want to do a different model. It might have nothing to do with GPT-2, it might be another one. So I wanted a place where all of that data could go, all the models. So obviously most likely it's going to also be a Hugging Face one. So basically what it'll do is it'll put, we say models, and it'll put the cache, for example, let's say llama, it'll be, models hyphen llama, right? So that's why I did this. So this way, if I want to go back to this in the future, or if I want to use another one, it'll already be there for me. Now that's the reason. Now, of course, because I know this is the cache, I can obviously just zip it up and put it somewhere else on another server as well. But say it doesn't take too long because it's a very small model. So is this, okay, let me zoom out here. Is this 37 gigs? That doesn't make any sense. Let's see. Oh, 3.4. I thought it was 37. Okay, so 3.4 gigs. So it's gonna be it needs to go about another gig. Am I right? Okay, about 1.5 1.6 gigs it has to go. So while that's running, I want to show you, yeah, I'll just let that continue running. So let's go back to the article and finish while this is running. So so the first thing as we did is we prepared our custom data set, and I showed that to you. It's basically a collection of text files, but we're just going to create one text file with 100 samples. So for this guide, we assume you have a text file called custom_data.txt with the text data you want to use to fine-tune the TinyGPT. So the reason I changed my mind, even though I said I'm going to use a JSON data set, I wanted to use text because I wanted to make it as simple as possible. If I introduce JSON, it would be more difficult. For example, I might have to escape, some double quotes or what's the other one? Single quotes. I didn't want to do that, so that's why I decided to make it text. In a future one, I might actually go back to I might do a JSON, but I said that's why I also made 100 samples just to make it easy. Okay, so basically what will happen is the script will read the text file, the custom_data.txt, and process it, saves it in the data assets format. Okay, and then we also created the training script, which will fine-tune the TinyGPT 124M using the custom data set. Okay, and then what else? So basically we'll load the GPT model and tokenizer. I already explained this. Tokenizes the custom data set, fine-tunes the model using trainer from Hugging Face Transformers library. So that's another good thing about Hugging Face, is they do people have contributed to have some some Python dependencies to make your life easier, because otherwise you have to write all this yourself. For example, even a company like NVIDIA has also contributed, so just makes everybody's life easier for training. And the good thing about this is you can have this, for example, this model is a 124M. It will be a little slow on, for example, on a Raspberry Pi, but if you have an old phone, for example, it will just fly by. So you could have your phone training, and this is a very simple thing to do. I'll show you the training part later. So you could have this on your workstation or remotely, and just have the Raspberry Pi do the training and keeping all that data sets. Pretty impressive. And even if you have a Raspberry Pi, so it'll be a little bit slow, who cares? It's like it does. I can see here it's now on top, step 2 of 7 of the Docker file, and it's running step 3. This one is going to take a while as well, because it has to install the transformers, which is actually a pretty big data set as well. Okay, so then do save, as I said there, do save the fine-tune model to the /mount/models as TinyGPT hyphen fine-tuned, and then we can run our testing script. So I didn't want to make this too complicated, so I did have code where you run you could run the test before the training and after the training. The reason I removed that was because it was really complex, because it basically has to run, and sometimes it wants to reinstall transformers and stuff, and I was like, let's just skip that part, because we're going to have our own custom data set, so we know it will be running pretty well. So as you can see here, you see now it's actually doing the training samples, and you can see the reason it went much faster is because I guess I do have those dependencies installed somewhere when I ran this the first time. As you can see now, it finished training the 100 sample sets. Let me actually zoom out here a little bit. What's going on? So you can actually read it a little bit better. You see it says generating training split 100 samples 00. Then you see the examples, and then you see it says 0%, and then it finished at 100%. So 100 out of 100, and you can see the examples it created. And then you can ignore this one. It's not it's unrecognized. Everything is fine. You see it's 100 out of 100, and you can see the training. It's finished. It's training samples. Train_samples per second 1.9.26, and then you can see training steps per second 0.25. So you can say, oh, that's very slow. You have to remember, I'm not using the GPU, so I'm saying this can run it on a low-end device, because I said or device that just a GPU, and it can also run, for example, on an old laptop to use less power. Obviously, a laptop uses more power than, say, a Raspberry Pi, but you get my point. So what I'm trying to say is that the training is complete. See, it says model and tokenizer saved in the cache directory. So let's go back to that cache directory. As you can see here, so the model is obviously saved in here. And to prove it to you, for example, if I right-click this and I go to properties, I should have put this here. I guess I have to close it first. So when I right-click this, bear in mind today's date. So obviously that the photo was created. Okay, that doesn't. Did it? Oh, I should have used the command line. I guess I should have used the command line. I don't know where it's saved. Is it the datasets? Okay, there we go. See, modified. So I guess it didn't touch the. Oh yeah. I misspoke. I remember I told you that if it's already downloaded the model, it won't touch it. So that's why it was a little bit fast. So obviously the one it did was the datasets, because the datasets obviously changed them by random. So you can see here today's date, and the last time I did this was days ago. Okay, so that's what I wanted to show you. So now we're going to run our test here, test.py. All right, so in order to run our test.py, I'm gonna, you see, once once everything finished, it says training complete, model and tokenizer saved to cache directory. Okay, fair enough. Now when you get back after that, you see I'm running Linux obviously in the command, and when I get this greater than sign, it tells me that everything is finished and I can type again. So what I'm going to type is Podman Compose run TinyGPT train, and I'll type Python 3. It's based on it's based on Debian. So Debian, I think Debian might have some Python 2.7 stuff here. So if you want to use the specific Python, you gotta put Python 3. As I said, I'm running on Fedora Linux locally, so I don't need to type Python 3 because they no longer use anything but Python 3. But Debian might, or some other Linux or other operating system must be used. Hopefully they don't, but they might still use some older ones. Anyway, so after that I type, so one more time, Podman-compose space run space TinyGPT-train space Python 3 space /mnt for mount, and then scripts /test.py, because remember our test.py was there we go. Obviously press enter after that. So our test.py was actually this file here, this one. It was actually copied into the container. So I'm not running it locally, I'm running the one that's inside the container. So with that said, let's read what it says. It says the attention mask and the pad token ID were not set. As a consequence, you may observe unexpected behavior. Please pass your input's attention mask to obtain reliable results. Setting the pad underscore token underscore ID to EOS underscore token underscore ID for open-ended generation. So again, I ignored that because I said this was just first crack at training, and it worked, and I'll prove to you. So the next one it says is the attention mask is not set and cannot be inferred from input because pad token is the same as EOS token. As a consequence, you may observe unexpected behavior. Please pass your input's attention mask to obtain reliable results. Input. So the input was the weather is great today, and the generated task is the weather is great today and the sun is shining brightly. The forest is beautiful and the trees are growing. The forest is peaceful and the sun is shining brightly. The forest is peaceful and the sun is shining brightly. The forest. Okay, so obviously there are a few tricks you can do, but I just wanted to give you guys a quick introduction into how you can train your a LLM simply. So what I do intend to do in the future is I will take something like this, most likely this one or a coding one, and then I can train it to be able to answer. You know how I always ask it the same 5 questions, like who's the mayor of Toronto, those type of questions. So what I do hope to do is I hope to train this maybe this AI or a different one, and you'll be able to answer the questions that I ask it. So I know it's going to fail because the one is way too small. It doesn't have those answers. This is not a coding one, but I'm just going to give you an example of how you can get it up and running pretty quickly. Obviously, what I also want to do is not just to output an answer like this, but maybe put it in a web browser so that the answer it gives would be like nicely, maybe do like a markdown type thing as well. So anyways, that's the end of the coding part of the tutorial. And as you can see, you can run this. Now, I always tell people, one of the things I always dislike is when people teach you this type of tutorials, they don't tell you how to remove everything you've done. I'm going to show you that. So that's a bonus. So for example, if you type Podman space ps space -a, see, it's telling me that I'm running 2 of the as you can see, one was for training and the other one is because remember when I did the tests, right? So it's running 2 of them right here. So I want to close both of them. So the easiest way to do that is just type Podman -compose, then done. You see? Now if I type that command again, you see they have stopped. However, if I type Podman images, you see it has these images. You see it has PyTorch, Python, and the TinyGPT train. So and you see how big that is, 8.1 gigs. Remember I told you it's going to double. If you remember when it was downloading, it said it was about, if I remember correctly, it was I think 3 point something gigs or something like that. And you see how big it became, because I said it's going to double, because we have two models. One is the base model, and one is our one where we actually do the training. So that's why you see how big that is. Now obviously if you have space, you can leave them, but I'm not going to touch this for a while, so I'm going to show you how to actually remove it. So there's a couple ways. You can obviously do it manually. So another thing also is there's also Podman volume ls. Oh, this one you didn't have, so you can remove this as well. So it's very simple. You just type Podman and then space RMI means remove image, and then obviously you can grab the image ID, you put it there, that will remove it. You can also remove all of them. So I'm going to remove everything, and I'll show you how to do that. How big is this one? Ghost. Actually, I think I'm doing Ghost tomorrow, so I'm going to leave Ghost. So I'll remove this all tomorrow. I'm going to leave it for now. So basically, if I want to remove everything, I just type Podman space system prune -a, and then it will say, are you sure you want to continue? So I want to say no for now, but I'll do that in tomorrow's tutorial. I believe it's tomorrow's tutorial. Yes, so with that said, let's finish up this tutorial. Let's go back to the article. As you can see, I have all the code snippets, everything here for you guys. You see the Python, it's expand to get all the Python stuff, and you see the Docker file and the YAML file here. Here you see I actually put 3.8, as I said, and the one I actually used was 3, so I said that won't make much of a difference. And you can see here how to build, and that's it. And here the screenshots, as you can see, very similar to what we did today. And this is the live stream. So as you can see, I'm doing this actual live. All right, now, so for example, if you have your own data set, you can ask it something like the future of AI is, and then it will say uncertain. So, or whatever answer you want when you're training it. So you can train it in anything you want. I said this is just a basic one where it builds on, elaborates on something you ask it. Okay, so in conclusion, in this guide, we walked through the process of training TinyGPT 124M LLM using Podman Compose containers. We created a custom data set, written the necessary training and testing scripts, and containerized the entire workflow. You now have a trained TinyGPT model that you can use for various NLP tasks. Before I continue here, I want to let you know that you can continue, you can have different data sets, so it's going to keep that and just keep on growing as well. So as I showed you, hopefully you guys enjoyed this. If you're interested in learning more about Python, check out my book, Learning Python, which is available on Amazon. Links are in the description, or you can get my online course, Learning Python, on ojamboshop.com. Links are also in the description. I also offer one-on-one online Python tutorials. I can help install, train, and migrate TinyGPT or any other LLMs. You can contact me on ojambo.com/contact, or go to ojamboservices.com/contact. And also be sure to subscribe, like, follow, and leave comments for more frequent content. I want to thank everybody who subscribed so far last month and this month. Keep it up. It motivates me to keep on making tutorials like this. So if you guys do enjoy this type of tutorials, let me know. I can actually keep on training this one or train another one. So let me know. I wasn't too sure about this tutorial because I wanted to make it as simple as possible, some things. So I think doing a container is actually the simplest way. And once you get it running like I did, so we did this in live. We did it live, which is pretty amazing if you look at the time. Okay, with that said, I'm checking the live chat to see if there's any chat requests. I don't see any, so I'm going to stop this live stream and wish you guys a great day, and I'll see you guys tomorrow. Bye now.